Page 253, Section 5.2, Try It Yourself, Number 1. A Ford Focus manual transmission gets an average of 24 miles per gallon in city driving with a standard deviation of 1.6 miles per gallon. A Focus is selected at random. What is the probability that it will get more than 28 miles per gallon, assuming gas mileage is normally distributed? And so what we're given here is we're asked to find the probability that X is greater than 28 miles per gallon. And we're told that the average, or the mu, is equal to 24 miles per gallon. And this standard deviation, or our sigma, is 1.6 miles per gallon. And so we're going to use our z formula. Our z formula is x minus mu over sigma. And so we're going to change this. We're going to actually find the probability that z is greater than, and in place of the x, we're going to put our 28 minus the mu, which is 24, divided by the 1.6, which is our sigma. And so when we do this, make sure you press enter after you subtract or put parentheses around the numerator. You'll end up with the probability that z is greater than 2.5. So we put that on our curve here. 2.5 is positive, so it's the right of 0. So we're trying to find all the area greater than this 2.5. And so I use the alternative method. I'm going to show you that table in a second. And so the table tells us the area between 0 and 2.5, but we don't want that. So we're going to take 0.5, which is the area from here to forever, 0.5, and we're going to subtract this area to find out what's greater than 2.5. So we're going to take our 0.5, and we're going to subtract what we get when we look up 2.5. So when we go to our alternative in Appendix A, and I'm going to post this on Moodle also, you'll have this there. You look up 2.5, you go down to 2.5, and the hundreds place is 0. So that's just 0.4938. So we're just going to subtract 0.4938, and so the probability is going to be 0.0062, which is less than 1%. Page 254, Section 5.2, Try It Yourself 2. A survey indicates that for each trip to the supermarket, a shopper spends an average of 45 minutes with a standard deviation of 12 minutes. That information was from the example on the same page. What is the probability that a shopper will be in the supermarket between 33 and 60 minutes? And so the first thing we want to do is write down the information that we know. So we know that the mean is 45 minutes. And the standard deviation, our sigma, is 12 minutes. We're trying to find the probability that the shopper is going to be in there between 33 and 60 minutes. So that's going to be 33 is less than x is less than 60. So again, we're going to use our formula for z is equal to x minus mu over sigma. So in this case, we're going to try to find the probability that our x here is 33 minus the mu, which is 45, divided by our sigma of 12, is less than z is less than, and now we're going to do the 60 minus 45 divided by the standard deviation, which is 12. So when you calculate each one of these, and make sure you press enter before you divide, it's going to be from -1 to 1.25. So this gives you -1, and this gives you 1.25. So let's draw that on our graph. And so we're going to go from -1 on the left of 0 to 1.25 on the right of 0. So we're going to look up -1. It's going to give us this area that we want. And we're going to look up 1.25, and it's going to give us this area using the alternative method. And so your table for the alternative method is going to give you the area from 0 to -1, and then from 0 to 1.25. And we're just going to add those together. So let's look those up. So we look up -1. It's just like looking up 1. So that's going to be 1.00, so it'll be 0.3413. And then 1.25 be 1.2, and over to 5, way over here, give us 3944, 0.3944. And so we're going to go back and add those together. And so that's going to be 0.3413 for the -1, for 0 to -1, and then 0.3944 for the 1.25. So we'll add those together, and that'll give us 0.7357. So that's the probability that it's between the -1 and the 1.25, or that the shopper's in there between 33 and 60 minutes. Now for part D in the problem, it asks you if there's 150 shoppers in the store, how many would you expect this to be? So we're just going to take our 0.7357, just leave it as a decimal, and multiply it by that 150 in your calculator, and you'll end up with about 110 shoppers. So that's how many would be in the store for that length of time.